Hello everyone, welcome to new class. Today's class is about network theorems. So, network theorems are very important in electric circuit. So, there are about 10 network theorems. So, let us study about each theorem in detail. First one is superposition theorem. So, the superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of the responses caused by individual sources acting alone while the other sources are non-operative. That is, while considering the effect of individual sources, other ideal voltage sources and ideal current sources in the network are replaced by short circuit and open circuit across their terminals. So, this is the superposition theorem. So, let us study in detail. So, consider a network like this. Let R1, R2 and R3 be the resistors and V and I are the voltage sources and voltage and current sources. So, here this network contains two sources. So, here first of all we will inactivate one source, then consider one source. That is, suppose if we are considering this voltage source, then this current source we have to inactivate. So for that, this current source is open circuited. Then find the values of current in each branch. Then in the next step, we will inactivate this voltage source. So to inactivate this voltage source, short circuit there. Then find the current in each branch. Then finally add the currents obtained in both the cases. That is the step in this superposition theorem. That is, take only one independent source of voltage or current and deactivate the other independent voltage or current source. So for the voltage sources, remove the source and short circuit. Then for the current source, just delete the source, keeping the respective terminals open circuited, and then obtain the branch currents. Then repeat the step for each of the independent sources. Then to determine the net branch current utilizing this superposition theorem, just add the currents obtained in step 1 and step 2 for each branch. That is, in step 1, consider only one source. Suppose if we are considering voltage source, then deactivate current source. That is, open circuit this current source. Then find the branch currents. Then in step 2, consider this current source, then short circuit voltage source, then find the branch current. Then in the third step, to obtain the net branch current, that is we have to obtain the net branch current, just add the currents obtained in step 1 and step 2 for each branch. And in that case, if the currents obtained in step 1 and step 2 are in the same direction, then just add. So if same direction, we can add the currents in each branch and subtract if opposite direction. So that is about the superposition theorem. Let us do an example. Find the current in the resistors using superposition theorem. So this is the given network. So here there are two sources. One is voltage source and other is current source. And the currents are I1, I2 and I3. So we have to find these currents using the superposition theorem. So our first step is consider one source. Let consider 4 volt, that is the voltage source acts alone. Then redraw the network. So it will be, this is 4 volt, then 2 ohm resistor, here 2 ohm resistor, then 4 ohm resistor. So while considering this voltage source, we have to deactivate that current source. So it is open circuited. Now mark the currents. So here this is I1 dash, because the original currents are I1, I2, I3. So in the first step we have to mark I1 dash. Then here this current will be flowing in this direction. So I1 dash. Then here this is I2 dash. Then I3 dash. Now we have to find each branch currents. And here we can write I3 dash is equal to 0 because this branch is inactive. Now we have to find I1 dash and I2 dash. Then I1 dash is equal to, this is the voltage, that is V divided by R form we can find, that is 4 divided by total resistance, that is 4, equal to 1 ampere, and which is same as I2 dash, because this same current flows in this direction. I3 dash is 0. So I1 dash is equal to 1 ampere, which is equal to I2 dash. Now consider 2 ampere current source acting alone. That is step 2. Consider 2 ampere source acts alone. Then redraw the network. That is, here we have to short circuit this 4 volt voltage source. Then this is 2 ohm. Here again 2 ohm. This is 4 ohm. And here current source. And this is 2 ampere current source. And here the current direction is in this way. So this is I3 double dash, and this current splits like this. So this is I1 double dash and this is I2 double dash. Now we have to find the values of currents. And here I3 double dash is equal to 2 ampere. That is I3 double dash equal to 2 ampere. Now we have to find I1 double dash and I2 double dash. I1 double dash is equal to the total current into the resistance through the other branch, that is 2 ohm, divided by total resistance, that is 4, and that is equal to 1 ampere. Then I2 double dash is equal to total current 2 ampere into resistance through the other branch, also 2, divided by total resistance equal to 1 ampere. So here also I1 double dash and I2 double dash equal to 1 ampere and I3 double dash is 2 ampere. Now next is step 3. So in step 3 we have to add the currents to find the net current, that is we have to find I1. So I1 is equal to, here I1 dash in this direction and I1 double dash in the opposite direction. So these two are in opposite direction, so we have to subtract, that is I1 dash minus I1 double dash is equal to, I1 dash is 1 ampere, I1 double dash is also 1 ampere, that is 0. Then I2 is equal to I2 dash in this direction, I2 double dash same direction. So I2 dash plus I2 double dash equal to, I2 dash is 1 ampere, I2 double dash is 1 ampere. So equal to 2 ampere. Next is I3. So I3 is equal to, here I3 in this direction and here I3 dash is in this direction, I3 double dash opposite direction. So I3 dash minus I3 double dash, that is here this is 0. 0 minus 2, that is equal to minus 2 ampere. So these are the values of branch currents using superposition theorem. So I1 is equal to 0, I2 is equal to 2 ampere, I3 is equal to minus 2 ampere. Let us do another problem. Find the current from the source using superposition theorem. So this is the source. So here we have to find the current from this source. So first of all mark the currents. So let this current be I1. So there are 3 loops. So let this be I1. Then this is I2. Then this is I3. So these 3 are the currents. So here we have to find the value of I1 using superposition theorem. So there are 2 voltage sources here. So first of all consider one source, then deactivate the other source and find the current I1. Then again do the same procedure for the other source. So step 1 is consider this 1 volt voltage source is acting alone, that is 1 volt is acting alone. Then the other voltage source, that is 2 volt, we have to short circuit here. Now mark the currents. So this is I1 dash, then this is I2 dash, then this is I3 dash. Now we have to find I1 dash and no need to find the values of I2 dash and I3 dash. So here mesh analysis by inspection method, we can find the value of I1 dash very easily. That is in R into I is equal to V form, we can write the matrix. Here there are 3 loops. So this is a 3 by 3 matrix. So R11 is the self resistances, that is 6 plus 5 plus 10, 21. Then R12, that is R12 is Between these first loop and second loop, there is 6 ohm resistor, and here the current direction is I1 dash in this direction, I2 dash opposite. So this is minus 6. Then next is R13, that is mutual resistance between first and third loops, that is 5 ohm, and here also I1 dash in this direction, I3 dash opposite. So this is minus 5, and here also R21 is minus 6. Then R22 is self resistances in the second loop, that is 6 plus 2 plus 8, that is 16. Then R23 is mutual resistance between second and third loop, that is 8. I2 dash in this direction, I3 dash opposite, that is minus 8. Then this is R31. 31 is minus 5. Then R32 is minus 8. Then R33, that is self resistances in this third loop, that is 8 plus 4 plus 5, that is 17, into this is I1 dash, I2 dash, then I3 dash, equal to, in the first loop the voltage is 1 volt and current direction is same as that of this 1 volt. So this is positive 1. In the second loop and third loop there is no voltage source, so 0. Now we can find the value of I1 dash, that is I1 dash is equal to delta 1 divided by delta. Now we can find the values of delta 1 and delta. Delta is the determinant of R matrix, that is determinant of this matrix, and that is equal to 21 into 16 into 17 minus 8 into 8, that is 64, then plus 6 into minus 6 into 17, then minus 40, then minus 5 into 6 into 8, that is 48, then plus 5 into 16, and that is equal to 2876. Then to find the value of delta 1, change the first column elements with the voltage elements, that is 1 0 0, minus 6 16 minus 8, then minus 5 minus 8 17, equal to 1 into 16 into 17 minus 64, then plus 6 into 0, then minus 5 into 0, that is equal to 208. So I1 is equal to delta 1, that is 208 divided by 2876, that is equal to 0.072 ampere, I1 dash. So this is I1 dash. Now we have to consider the next voltage source. So next step is consider this 2 voltage acting alone. Then we have to short circuit this 1 voltage source. Now mark the currents. So consider this voltage source. So here this is minus 2 plus. So I2 will be in this direction. So both the currents will be splitting from these points. So this is I2 double dash and this is I3 double dash. So I3 double dash in this direction and I2 double dash in this direction. Then let I1 double dash be in this direction. Now by mesh analysis, by inspection method, we can write the matrix. So in matrix form, we will get 21 as the first loop's self resistances, that is 6 plus 5 plus 10, 21. Then next is R12 is the mutual resistance between first and second loops. So here I1 double dash in this direction, I2 double dash in the same direction. So this is plus 6. Then here between 1 and 3, this is 5. I1 double dash and I3 double dash opposite direction. So minus 5. Then this is 16. Then between second loop and third loop, this is 8 ohm and the current directions are same, that is I2 double dash and I3 double dash in the same direction. So this is plus 8 and the self resistance are same as that of the above case. So this is the matrix form and this is I1 double dash, I2 double dash and I3 double dash equal to, in the first loop there is no voltage source, so 0. In the second loop the current direction and the voltage source are in same, so plus 2. In the third loop also the current direction and this voltage source are in same direction, so this is plus 2. Now we can find the value of I1 double dash. I1 double dash is equal to delta 1 divided by delta. So after computing, we will get delta 1 is equal to minus 28. That is delta 1 is changing the first column elements with the voltage elements. Then find the determinant and we will get minus 28 and delta is the determinant of this R. That is delta is equal to determinant of R and that is equal to 2876 and we will get the value of I1 double dash equal to minus 9.74 into 10 raised to minus 3 ampere. Now we can find the value of current from the source. So current from the source, that is from the 1 volt, is I1. I1 is equal to, here I1 dash in this direction and here that there also I1 double dash in the same direction. So we can write I1 dash plus I1 double dash, that is equal to I1 dash is 0.072 plus I1 double dash is minus 9.74 into 10 raised to minus 3 and that is equal to 0.062 ampere. So this is the current from the source. So I1 is equal to 0.062 ampere. So this is the superposition theorem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.